So we have derived the relation for pressure, where the pressure is P naught plus rho g hc, and hc is related with yc sine theta, and yc, we have found that already that yc relates with first moment of area using that relation. But there is going to be some force that is going to act on it, so we need to find out line of action of force and its distance from the origin. To do that, we have the same body and we have known distributed pressure on it. And we have a resultant force, and that force, according to the origin, it is at a distance yp. So this distance going to create some momentum about the centroid. So to find out that momentum, we need to multiply yp with fr, and that will give us momentum. So we refer to this figure. Yp fr is basically integral of y, and the fr is going to be pressure times area. Now we know already what is pressure. Pressure is going to be P naught rho g y sine theta times dA. So we can say it is going to be integral of y P naught dA plus integral of rho g y squared sine theta times dA. So I just go here. So we can say, if we take pressure out of it, integral of y dA plus rho g sine theta integral of y squared dA. Now dividing this by a and multiplying it with a won't make any difference. Rho g sine theta y squared dA. Now 1 over a integral y dA, that will give us centroid location. That is going to be, so it is going to be P naught a y c plus this part here is known as second moment of area about origin. So it is going to be rho g sine theta I x x comma o. Now I second moment of area about a region is related with second moment of area about centroid using following relation. So Yp Fr becomes P node Yc A plus rho G sine theta times second moment of inertia about a region. Now you know Ix XO second moment of inertia by region is related with second moment of area about centroid using following relation. And Fr is basically P naught plus rho G Yc sine theta times A. So if I call it equation 1 and I call it equation 2, we substitute these equations into this equation and write relation in terms of Yp. We get Yc plus Ix x comma c all over Yc plus P node over P node over rho G sine theta times A. For P node equals 0, like we just ignore the effect of atmospheric pressure, then Yp becomes Yc plus Ix x comma c whole over Yc. Okay, so using this relation you can find out Yp if you know the centroid location and if you know the second moment of inertia about the centroid. So centroid and centroidal moment of inertia or some common shapes are given here. So for example, for a rectangle or a square, the centroid is going to be A over 2 comma B over 2. And the second moment of inertia about the centroid is going to be AB cube over 12. Now you know the formula. Yp is equal to Yc plus Ix x comma c over Yca. So let's say Yc is basically B. In Y is C is going to be B over 2 and Ix x comma c is going to be AB cube over 12 times Yc is B over 2 times area is going to be A into B. So B squared cancels out with B cube and it gives us AB. A cancels out with A, 2 cancel, and this 12, so we get basically B over 2 plus B over 6. So the answer is going to be 12 sorry, it is going to be 6 for B, which is going to give us 2 by 3B YP. So YP for a rectangle is going to be 2 over 3 times B, and the second moment of inertia is going to be Ix comma C AB cube over 12, and the area is A over B, and the coordinates of centroid is going to be A over 2 comma B over 2. In this way you can find out centroid for circle, for an ellipse, for a triangle or other shape, semicircle for example. I hope it is clear to you now how to find out YP. So some special cases. You all know the formula for FR. General formula is P naught plus rho G YC sine theta whole into area. Now the case 1, a tilted rectangular plate which has the total length is B, so the centroid is going to be in the center, which is going to be B over 2. So FR in that case is going to be P naught plus rho G YC. From the origin it is going to be S plus B over 2 sine theta whole times area, which is basically A times B, where A is the width of this rectangular plate, which is actually goes inside this slide, and this relation is given here. When it is perfectly vertical plate, we will use the same relation, and FR will become P naught plus rho G. Again, centroid is going to be B over 2 S plus B over 2 whole times area, which is AB, and sine 90 is going to be 0. Sine 90 is going to be 1. Now for a perfectly horizontal plate, we go back to the basic. FR is going to be P naught plus rho G H whole times area, which is AB. So these are the some special cases for rectangular plate. So for rectangular plate, what you need to know is you just need to know the centroid location. So in that case it was B over 2. For a perfectly horizontal plate, it's the height of the fluid above that horizontal plate that will dictate the pressure. Now let's go through example 3.8. A heavy car plunges into a lake during an accident and lands at the bottom of the lake on its wheel, as shown in this figure here. The door is 1.2 meter high and 1 meter wide. So wide is 1 meter and the height is 1.2 meters. The top edge of the door is 8 meters below the free surface. So there is a free surface and that distance is 8 meters. Determine the hydrostatic force on the door. So this is the first thing that you need to determine, the hydrostatic force on the door. So to find out hydrostatic force, you need to find out hydrostatic pressure. So the pressure is going to be rho g hc, and hc is going to be yc is 1.2 over 2. This is where the centroid is going to be plus 8 meters, or in other words rho g s plus b over 2. S is going to be 8 and b is 1.2 over 2. So you substitute these values and you get the answer 84.4 kilonewton per meter squared. Now you need to find out force. Force is going to be pressure times area. We know the pressure, we have the parameters for area, and we can find out resultant hydrostatic force 101.3 kilonewton. All this is being used for the unit conversion. So just be consistent when you are solving it by yourself, that there has to be consistency in the units. I will leave it up to you to have a look at it and understand it. Now the second part is and find the location of the pressure center. So find out location of the pressure sensor. You know the formula for Yp, and Yp is basically Yc plus moment of inertia above the centroid over Yc into A. Now Yc is S plus B over 2. I is basically AB cube over 12. And you know Yc, you know area, A times B. You solve it and you get this expression. Substitute these values and you find out answer 8.61 meters. Now the last step is discuss if the driver can open the door. Now you know force is mass times acceleration, or in terms of weight it is mg. If a person weighs 100 kilograms, then g is 9.8, so it becomes basically 0.98 kilonewton, or you can say maybe 1 kilonewton. A person generally, a strong person can lift 100 kilograms, or he can apply a force of 1 kilonewton. On the other hand, the hydrostatic force which is being exerted on the door is 101.3 kilonewtons. It is almost 100 times higher than the force that a strong person can apply. So a driver won't be able to open the door. Now, if a driver wants to open the door, what he needs to do is he needs to just slightly open the window and let the water come inside the car. And he has to keep his head high so that he can breathe, When the other side of the, like inside the car, the water will be filled, then the situation will be like this. It will be a rectangular plate that has kind of equal pressure on both sides. And then the driver will be able to open the door just like he can open it in the air. So that's it for the for this example. Thanks a lot for your time. And if you have any questions, you can ask me now. Allah Hafiz.